Hello students, welcome back. Previously we went through the direct variation and the inverse variation. Here's the direct variation. We have straight up multiplication, y equals kx, where k is a constant that doesn't change, and what x and y are variables, and they do change, and they're related. And they're related in terms of the direct variation. If x is doubled, tripled, quadrupled, then y is also doubled, tripled, quadrupled, and so on, and vice versa. On the other hand, this one is called an inverse variation. It's not a multiplication, instead we have division. K times 1 over x. X and y are variables, and k is constant, as before. Here, x and y are related inversely, or they vary inversely, okay? X is doubled, tripled, quadrupled, and y is not double, tripled, quadrupled, but it is halved, 1/3, and 1/4, kind of like that, and vice versa. You can use this idea to get these kind of problems in a little bit easier way like this. So in this case, b is 120-folded, then so is m. And in this case, L is 2.5-folded, then W is inversely 1 over 2.5-folded. So you can answer these questions like single steps using the concept of direct variation and inverse variation. But I didn't recommend those methods. Instead, I advise you to take hard method, 4-step process. Variation equation, plug in the numbers and find k, plug in the k value into the original equation and get the completed equation. Because this one is incomplete, we don't know what k is. Now we know k, so this one is completed. So let's use completed usable equation and get the final answer. Same goes here, the 4-step process. Why did I do that? Why did I emphasize hard method while easier method was available? That's because I had this in my mind. Joint variation. What is joint variation? More than one variations put together. Here's an example. How many variables are there in this problem? There are 5 variables. K is a constant that doesn't change. It is called either variation constant or proportional constant. In any case, this is constant, it doesn't change. The others are all variables. And how are they related? How do they vary? Quantity C varies directly with U. So this is going to be a multiplication, and indeed, U is in numerator. It is indeed a multiplication. I need even bigger font here. Next, varies directly with V squared. Not just V, but V squared. So it's a multiplication by V squared, and there you go, it's in numerator. Direct variation is multiplication, so they go to numerator. How about the inverse variation? Varies inversely with x, so that's division, and consequently that goes to denominator, and we have one more here. Varies inversely with y cubed, so y cubed goes to denominator, like that. And you can change those powers. If this one says not just y cubed, but say for example square root of y, then you have to change this one into square root of y. The problem will probably given like this, inversely with the square root of y. The problem will be probably given like this, and then you'll have to write like this. And also, instead of directly with v squared, it's more likely the problem will say varies directly with the square of v, like that, so that you'll have to understand what it means by the square of, and put the square here. So that's joint variation. Far more complicated And consequently, we need that 4-step process because the single-step method will not work because there are 4 variables here. So even if the single-step method works, we'll have to do it 4 times. So it's not any better than the 4-step process. But of course, the single-step process doesn't work here. All right, we went through joint variation. Let's do an example problem. Here we go. The strength S of a rectangular beam of wood varies jointly with the width W and the square of the depth D, and inversely as the length L of the beam. So if the beam is longer, then if you put some large weight, big weight in the middle, then the beam is not going to hold it very well. As for the width and depth, they're actually helpful, especially depth is quite helpful because it is proportional to the square of the depth. So it's a structural kind of problem. Okay, all right. And let's write that variation equation. Remember the 4 steps process? Step 1 is the variation equation, and let's get it done. S is equal to K times, okay, times something. All right, what goes to the numerator? The direct variation. Varies jointly with W and the square of depth D, the problem says. Did not specify directly, but if it doesn't specify, then it's a direct variation. So W goes here, and D squared goes there, and those are direct variations. Now the problem says inversely as the length L, and the problem specifically said inversely, so L goes down here, and let's use red font. Kind of color coding. L is inverse variation, red. W and D squared are direct variation, blue. All right, we have this variation equation, but this equation is actually incomplete because we don't know the K value yet. So let's find out. How do we find out? Plug in all those values and find out K. We have S equals to 90, W is 2.0, D is 1.5, L is 14.0. We have all those numbers here. From here we can find out the K value like this. 90 is equal to K times W is 1.5. No, W is 2.0, excuse me. D is 1.5, and then divided by 14.0. Okay, from here, let's find out G. We can find out K, excuse me. Why did I say G? I don't know. Let's find out K. All right, we have all these multiplication and division, so flip it over to the other side. K is equal to 90, which was there before. And then I have to multiply this one away to the other side. So this is 14.0. And then I have to undo those multiplications to the other side. So I have to divide those away. 2.0, 1.5. Flip all those over and then punch your calculator in. That's what you're going to get. So what do you have? What is your K value? Punch in the calculator and you have 420. So that is your K value. So that's step 1 and step 2. Is everybody happy with this? All good? Not really. I made a mistake here. What mistake did I just make? What did I do wrong? Right here, 1.5. That's where the mistake is. Remember, varies jointly with the square of depth D. So actually we need D squared here. And I wrote correctly here, D squared. I should have made a mistake here as well. So that should be changed into 1.5 squared. So flip it over to the other side, that should be changed to 1.5 squared. And now, of course, this computation has to be redone completely. So punch it to the calculator again. We get 280. That's the right answer. 420 is wrong. 280 is correct. What mistake did I just make? I forgot this square previously, but I corrected now. It's one of the common mistakes, actually. Okay, all right. We have step 1 and step 2. Step 1, we have the variation equation. Correct equation, but this is incomplete because we don't know what k value is. So let's find out. Plug in all those numbers and set up an equation of k and solve it, and then we have this k value. That's step 2. All right. Let's plug in this k value back into the original equation so that we can have the completed version of the equation. So S is equal to 280 times W times D squared over L. A bit bigger font is in order. We have fraction and power, so it's a bit hard to see this way. So we just found out k is about 280, so 280 goes here in place of k, and then all the others, well, they were as before. Okay, we now have a completed equation, so let's use it. What's the final question here? Find S, all right, when W is given and D is given and L is given like these. We have completed the equation, so we can do it. S is equal to 280 times W is 1.5, and then D is 2.0 squared, and then divide by 35.0. Did I do this right? Please check. And then let's punch it to the calculator. I'm going to get 48. And that is the final answer. So here goes the 4-step process. Step 1, variation equation. Step 2, find the variation constant. Step 3, put the variation constants in there so that we get a completed equation to use. Now we have usable equation, so let's use it to find out the answer. 4-step process. Same as before. Another summary here. Variation equation, step 1. Find the variation constant. Plug in the numbers and solve for k. Put this k value back into the original variation equation, and we have this completed equation. Okay, this is complete, so let's use it. Plug in the final numbers and then run your calculation. Okay, we went through the joint variation, 4-step process. We have one more example problem left, but looks like we won't have time to cover everything here, so let's postpone that. See you again soon.